A clear glass is required to observe the layering effect. Water acts as the base liquid for creating different density solutions. Sugar is used to increase the density of the water solutions. Food coloring, red, yellow, blue, green, helps differentiate the layers visually. A spoon is needed for mixing sugar into the water to create the solutions. 4 clear, small cups are arranged in a row. The cups are ready to receive different colored solutions. This setup allows for a clear visual comparison of the solutions. The arrangement ensures each solution is easily identifiable. Begin by adding water to the first cup. Ensure the cup is filled with an appropriate amount of water for the experiment. Next, add 1 spoonful of sugar to the water. Stir the mixture to dissolve the sugar completely. Introduce a single drop of red food coloring into the sugar solution. Observe how the red food coloring disperses within the water. Water is added to the second cup as part of the preparation process. 2 spoonfuls of sugar are then added to the water in the cup. The sugar is added to sweeten the mixture in the cup. A single drop of yellow food coloring is added to the cup. Begin by filling the third cup with water. Next, add 3 spoonfuls of sugar to the water. Stir the mixture until the sugar is fully dissolved. Introduce a single drop of blue food coloring into the solution. Observe as the blue color disperses evenly throughout the cup. The fourth cup's preparation begins with the addition of water. Water is poured into the cup as the primary liquid base. Next, 4 spoonfuls of sugar are added to the water. The sugar serves as a sweetener, altering the taste profile. A single drop of green food coloring is then introduced. The green food coloring is used solely for aesthetic purposes. A red solution is prepared in the first mixing cup. Sugar is added to the red solution. The mixture undergoes thorough mixing. Mixing continues until all sugar granules are fully dissolved. The result is a homogeneous sugar solution. A yellow solution is prepared in the second mixing cup. Sugar is added to the yellow solution. The mixture is stirred to dissolve the sugar. The stirring action ensures uniform distribution of sugar molecules. Continue mixing until the sugar is completely dissolved in the solution. A blue solution is prepared in the third mixing cup. Sugar is added to the blue solution in the cup. The mixture is stirred continuously to facilitate dissolution. Mixing continues until the sugar is completely dissolved in the blue solution. A green solution is prepared in a mixing cup. Sugar is added to the green solution within the cup. The mixture is stirred continuously. The stirring continues until the sugar is completely dissolved in the green solution. A clear glass is prepared to receive the green solution. The green solution has the highest sugar content. The green solution is poured slowly and carefully. Pouring is done to create the first layer in the glass. The controlled pouring ensures distinct layering. This layering effect visually demonstrates sugar concentration. A blue solution is prepared for layering. A glass container already contains a green layer at the bottom. The blue solution is carefully poured into the glass. The pouring process is executed slowly to avoid disturbing the green layer. The goal is to create distinct, separate layers of color within the glass. The layers remain unmixed, showcasing the density difference of the solutions. The demonstration involves pouring a yellow solution into a glass. The glass already contains a layer of blue solution at the bottom. The key is to pour the yellow solution carefully. The goal is to maintain a clear separation between the yellow and blue layers. This requires a slow and controlled pouring technique. Proper execution will result in 2 distinct, unmixed layers of liquid. A red solution is prepared as the final layer of a layered drink. The red solution is gently poured into a glass. The pouring is done slowly to maintain distinct layers. The red solution is added on top of a yellow layer. This completes the rainbow effect in the drink. The layered drink now showcases a full spectrum of colors. A rainbow effect is created using distinct layers of color. The layers are arranged to mimic the spectrum of a rainbow. The colors include green, blue, yellow, and red. These layers are visible through a clear glass container. The arrangement demonstrates the refraction and dispersion of light. A density gradient is formed when a substance varies in density across a given volume. In this demonstration, different colors represent liquids with varying sugar concentrations. Higher sugar concentrations result in higher density liquids. Liquids of different densities do not readily mix due to gravitational forces. The denser liquids settle below the less dense liquids, creating distinct layers. This layering effect is visually apparent because the liquids are dyed different colors. Dissolving sugar in water increases its density. Higher sugar concentration results in a denser solution. Density is defined as mass per unit volume. Increased density makes the sugary water heavier than pure water. The layering effect demonstrates how fluids of different densities arrange themselves. Denser fluids sink to the bottom due to gravity. Heavier, denser water will therefore settle at the bottom of a container. This creates distinct layers based on density differences. Water density is influenced by factors like temperature and salinity. Warmer water is generally less dense than colder water. Fresh water is generally less dense than salt water. Less dense water floats on top of denser water due to buoyancy. This density difference creates distinct layers in water bodies, preventing mixing. Density is defined as mass per unit volume. It is a fundamental property of matter. Density determines how substances interact when mixed. Denser liquids sink below less dense liquids. This is due to gravity acting more strongly on denser substances. The result is a stratification of liquids based on their densities. Sugar concentration directly influences the density of a solution. Higher sugar concentration results in higher density. Solutions with lower sugar concentration exhibit lower density. Visual gradients from red to green can represent increasing sugar concentration and thus increasing density. Visual separation occurs when distinct layers form due to density differences. These layers are often characterized by different colors or textures. Density is a measure of mass per unit volume. Substances with higher density will settle below those with lower density. This principle leads to the formation of visually distinct, separate layers. The clear separation highlights the effect of density on material distribution. The experiment visually demonstrates a fundamental scientific principle. It aims to make abstract concepts more tangible and understandable. Visual appeal enhances engagement and learning. The setup is designed for clear and effective observation. Data collection should be precise and systematic. Analysis of results will reveal underlying scientific truths. This review focuses on the key steps of the experiment. A critical aspect of the experiment involves pouring liquids carefully. Careful pouring is essential to maintain distinct layer separation. Maintaining layer separation is vital for accurate results. This experiment visually demonstrates the principle of density. Density is a key factor in determining how liquids layer. Liquids with higher densities will settle below those with lower densities. The layering effect provides a clear visual representation of density differences.